welcome to our video on reciprocal trigonometric ratios. Let's go ahead and take a look at example 1. Find the value for each trigonometric ratio. Before actually doing so, let me go ahead and refresh your memory in terms of what this reciprocal trigonometric ratios are. Okay, we have cosecant, so let me go ahead and write those for you. Cosecant of theta is the reciprocal of sine, so that's just 1 over sine of theta. Or, if you remember, sine was opposite over the hypotenuse, so this could also be written as hypotenuse divided by your opposite leg, okay? Notice how that is the reciprocal of your sine, so that's why we call this a reciprocal trigonometric ratio, okay? In a similar way, we have secant of theta. So secant of theta. Secant of theta is the reciprocal of cosine. So that is 1 over cosine of theta. If you remember, cosine was the measure of the adjacent leg divided by the hypotenuse. Here we get the reciprocal. So we're going to get hypotenuse divided by the adjacent leg. And lastly, we have cotangent. Cotangent is really the reciprocal of tangent. So we have 1 divided by tangent of theta. Okay? And tangent was defined as the opposite leg divided by your adjacent leg. So cotangent is your adjacent leg divided by your opposite leg. Okay, so those are the basic definitions for your reciprocal trigonometric ratios. Now let's go ahead and take a look at the diagram that we're given. Okay, notice we're given theta. Let's go ahead and label the parts. This will be your opposite leg. Now this is your adjacent leg. And this will be your hypotenuse because it's just across from your 90-degree angle. So this is your hypotenuse here. Okay, let me go ahead and call that x so we can actually figure out what is the value for x in that particular right triangle. Okay, to do so, we can use Pythagorean Theorem. So let me write it down as a squared plus b squared is equal to c squared. Okay, now the legs are both a and b, so let me go ahead and write 15 squared plus 20 squared, and that is equal to c squared. Now c in this case is the length of the hypotenuse. In this particular case we have x, so this is just x squared. Okay, now we have 15 squared, which is the same as 15 times 15, okay, plus 20 squared, which is just the same as 20 times 20. And we are going to go ahead and do the math because that will be equal to the x squared. So 15 squared, so we said is 15 times 15 will give you the 225 plus the 20 squared, which is 400, and all of that is equal to x squared. That will give you 625 is equal to x squared once you combine those two numbers. Okay, and in order for us to get the value for x, we take the square root, okay, because the square root will undo the square. And that will give us that the value for x is simply plus or minus 25. Now, in this case, we're dealing with lengths. Therefore, we take the positive root. So x will be 25, okay? With that said, we can say, well, let's go ahead and find cosecant of theta. Cosecant of theta is hypotenuse divided by the leg. So the hypotenuse is 25. Let me write it here. 25 divided by the opposite leg, which is 15. Now we're going to divide by 5, which is the greatest common factor. And notice that 25 divided by 5 is 5. And 15 divided by 5 is 3. Therefore, cosecant of theta is 5/3. Okay? Now let's do the same for secant. Secant is hypotenuse, which in this case we said is 25. Divided by the adjacent leg, okay? And the adjacent here is 20. So let's go ahead and divide by 5, okay? because that's the greatest common factor. 25 divided by 5 is 5. And 20 divided by 5 is 4. So secant of theta is really 5/4. Okay? And lastly, but not least, we have cotangent. And cotangent is adjacent leg divided by the opposite leg. So I'm going to take 20 here, divided by my opposite leg, which is 15. And I'm going to divide by 5, which happens to be my greatest common factor. And this is really going to be 20 divided by 5, which is 4, and 15 divided by 5, which is 3. So cotangent of theta is 4/3. Okay? So in a nutshell, we just needed to know the actual definitions for the reciprocal trigonometric ratios, and we needed to figure out what was the missing length here by using Pythagorean Theorem. Once you have that information, we just substitute the values and simplify our fractions into the lowest terms, and that will allow you to come up with these 3 trigonometric ratios. Okay? Now let's go ahead and take a look at another example. Example 2. Find the value for each trigonometric ratio. Okay? One more time here, I'm going to circle my theta and label the parts here. So the leg across from it, it's what we refer to as the opposite leg. Okay? The one that we use to form that particular angle is what we call the adjacent leg. And the side right across from your 90-degree angle is what we refer to as the hypotenuse. Now in this case, I'm going to call my hypotenuse x, so I can use Pythagorean theorem to figure out what is that value. Okay? So let me write down here, a square plus b square is equal to c square. So one of my legs is a 16 square plus the other leg square, which is 12 square, and that's going to be equal to x squared. Now, keep in mind what squaring means, okay? So in this case, 16 squared, it's really equal to 16 times 16, okay? Now, on the other hand, 12 squared is just 12 times 12, okay? So let's go ahead and do 16 times 16. That will give you 256 plus 12 times 12, that's 144, and that is equal to x squared. Now, 256 plus 144 will give you the 400. So 400 is equal to x squared. Now, we don't want the x squared. We just want the x. So in this case, we need to take the square root on both sides. So we get that x is equal to plus or minus 20. Since we're dealing with lengths, and lengths cannot be negative, we know that x will be the positive root. So x is equal to 20. Now, with that said, we know that cosecant, okay, is defined as the reciprocal of sine. And sine was opposite over hypotenuse, so cosecant will be the hypotenuse divided by the opposite here, okay? So cosecant will be hypotenuse, which is 20, divided by the opposite, which is 16. Let's go ahead and figure out what is the greatest common factor here, and that happens to be 4. So this is just 5/4. Why? Because 20 divided by 4 is 5, and 16 divided by 4 is 4. So cosecant of theta is 5/4. In a similar way, we can figure out what is secant of theta. Secant of theta is the reciprocal of cosine. Cosine was adjacent over hypotenuse, so secant is the hypotenuse divided by the adjacent. Okay? Now, the hypotenuse here is 20, the adjacent here happens to be 12. Let's go ahead and figure out what is the greatest common factor of 20 and 12. That happens to be 4. So 20 divided by 4 is 5, and 12 divided by 4 is 3. Okay? So secant of theta is 5/3. And lastly, but not least, we can find cotangent. Okay? Cotangent is the reciprocal of tangent. Tangent was opposite divided by adjacent, so this will be adjacent divided by opposite. And your adjacent here will be 12. Your opposite here happens to be 16. Let's go ahead and divide by the greatest common factor, which happens to be 4 as well. Okay, here's a 4 divided by 4, divided by 4. And we'll get that cotangent is 12 divided by 4 is 3, and 16 divided by 4 is 4. So cotangent of theta is 3/4. Once again, it's important that we label all the parts in the right triangle. You can also make sure that you use Pythagorean Theorem to find the length of the missing sides. And once you have that, you just make use of the actual definitions of the reciprocal trigonometric ratios. Okay? This concludes your tutorial on this topic. Thank you for watching, and good luck on your homework.